Alright guys, so today we're going to be whisking how to do the distributive property of multiplication. Please have this in your notebook. I will be checking it in class tomorrow. So let's jump right in. So the distributive property of multiplication. Right away, I can already tell you what type of math we'll be playing with today. We will be working with multiplication. Okay, so here is one way of designating multiplication in mathematics. But really though, I want you guys to think of this as being three groups of three. Okay, so three groups of three. That means we're going to be, again, multiplication is just repeating addition, so that would look something like this. This would be the expanded form. So 3 plus 3 is 6, plus 3 is 9. So when you see something like that, I want you to think of that. Okay. Next, we have 3x. One way of saying that is three groups of x. And in this case, x is just a variable representing an unknown. So one way to write that would be x plus x plus x. Okay, so I just wanted to show you how we designate multiplication in mathematics. So when you have a number, this is something that's called the coefficient. This 3 is the coefficient. It sits next to your variable. We'll go over more of that in class. All right, let's move on to the next one. Here I have example 1. So we're going to use area model of distribution or multiplication to multiply numbers without using the calculator. So it got cut off on your screen here, but this should say example 1. I do want you to write this down. So first, what we're going to need is to do area would be a rectangle. So I'm just going to draw a rectangle. And then the number that's sitting outside, since it's a single digit, I'm just going to put right there. That's going to be my width. And then I have 24. Now this gets a little bit tricky here. One way we want to look at 24 is the 2 would be the tens place, so that would be 20. Split my box up here. And that 4s is the ones place, so that's going to be positive 4. So again, you can tell that 20 plus 4 is the same thing as saying 24. So now we need to find the area of each little rectangle. So I'm going to do this one first. Okay, so that is going to be, area is the width times the length. So in this case it would be 160. And then I'm going to find the area of the second box. 8 times positive 4 will be 32. And then to find the sum here, we would just add these two boxes quickly. 160 plus 32 is going to be 192. So without using a calculator, we're using something called the area model of distribution, or in this case the area model of multiplication. 8 times 24 is equal to 192. And that's how you guys would use the area model of multiplication. Okay. This would be example 2. So here we have two groups of b plus c. In the last example, I forgot to say this, but we really have eight groups of 24. So when you have, you guys, we can write this out longhand, something that looks like this. If I have two groups of b plus c, so here's b plus c, here's another b plus c. And just like we did last week, we would combine like terms. Those two things match up, so I add them together, combining, so that would be 2b. The c's match up. Sorry, double should do different shape here. Double line. C plus c would be positive 2c. Okay. Some of you may start to see a pattern here, but if we're going to do the area of the area model multiplication, I'm just going to go draw my area here. Rectangles. Here's 2, the width. Here's b. Here's positive c. So basically, I'm just writing each of these as the length. 2 times b is going to be 2b. 2 times positive c is positive 2c, and I add them together. But since they are different terms, I can't combine them, so it's just 2b plus 2c. Again, same answer. Okay. So let's really get into the distributive property of multiplication here. What is going on? How do we quickly do this? So let's try it without the area model. I know the screen got cut off, but let's just simplify this. If we were going to do the area model, it would look something like this. To go 3 is the width, the length here is b, multiply them together, it would be 3b. The width here is 3, the length there is c, so it would be multiply them together is 3c, positive. So what I have is 3b plus 3c. But if I know that I'm multiplying the area of each box using the width and the length, why not just simply take the coefficient that's sitting on the outside right here and just multiply them straight across. Okay, 3 groups of b, 3 times b would be 3b. 3 times positive c would be positive 3c. I had a student a long time ago, probably 5, 6, 7 years ago, and one day we were doing this in class, and she's like, Mr. Wynn, it's like a double rainbow. I have no idea until she actually drew it. She actually used the colors, and I finally figured out that, oh yeah, it is a double rainbow. This is not called the double rainbow. This is called the distributive property of multiplication. I do have a picture of the double rainbow, though, in case you want to have a visual of what's going on here. Basically, we're multiplying our arcs. So 3 times b would be 3b, 3 times positive c would be 3c. Okay. Again, you can do the area model for this. I just did it earlier, and you should get the same answer. I would double check. Okay. So that would be 3b plus 3c, 3b plus 3c. 2 different ways, same solution. It's really up to you how you want to do it, but I highly recommend that you start moving away from the area model once you get it. The area model is good, though. We will practice that a lot. But for those of you that really want a shortcut, do the distributive property of multiplication using the rays or the arcs. So let's try something a little bit more complicated. I'm going to go jump right in without using the area model, and then I'll do it at the end. So here we have 3 groups of 4 plus 3r. The longest way to do this would be to write it out. Here's 4 plus 3r, one group. Sorry about that. 4 plus 3r, there's a second group. 4 plus 3r, there's a third group. And then I combine like terms. Okay, so squiggly, squiggly, squiggly. Those are all similar terms, so 4 plus 4 plus 4 is 12. 3r plus 3r plus 3r, those are similar terms. So if I have 3 r's each in each of these groups, that would be something like this, even longer. R plus r plus r. There's one group of 3 r's. R plus r plus r. Second group of 3 r's. Here's the third group. And all together, I have positive 9r. So that would be how you simplify this expanded form. Okay. Take a moment, write that down. That's the longer way of doing this. But if you see it like that, that's fine, because that is, you literally have 3 groups of 4 plus 3r. But a faster way would be just to do the rays, do the double rainbow. We're not calling the double rainbow method. It's still called the distributive property of multiplication here. And I'm just going to multiply it. 3 times 4 is 12. 3 times positive 3r is positive 9r. If that was a negative, that would be a negative 9r. Okay, so my coefficient there would be 9, and my variable would be r. So that would be how you simplify this without parentheses. I'm going to go ahead and tell you right now, common mistake. A lot of you will just do 3 times 4 and get 12, and then drop the 3r. You will forget to do the 3 groups of 3r. If that happens, that would be incorrect, because the parentheses says that's how many groups of whatever's on the inside. Let's try another one. Okay, simplify this. I have negative 2 groups of 1 minus, 1 and negative 5v. I don't want to say minus. You can look at it as going back to boxes here. I have two terms on the inside. I have a negative 2 groups of positive 1. Well, how do you have negative groups? Well, negative groups would be something similar to saying I have a positive and then the opposite of that. So I have positive 2 groups of 1 and then whatever the opposite. This sign out here usually means the opposite. Okay, so you can just do 2 times 1, which would be 2, and the opposite of positive 2 would be negative. Or you can look at it as negative 2. Okay, so let me redo that here. I'm just going to go this way, multiply them together. Negative 2 times positive 1, I know that's a positive 1 because there's no symbol in front of it, to be negative 2. Negative 2 times negative 5v will be positive 10v. At first, when we try this, some of you forget that that's a negative times a negative is going to be a positive. Again, if we're going back to our integer triangles and multiplying, dividing, if you have a negative and a negative, what's left is positive 10v. And that would be my final answer. Negative 2 plus 10v. I'm not solving for anything. I'm just simplifying it to get rid of the parentheses. Alright? And then this last one. I have negative, no number, 2 minus 3x plus 4. So this one's going to be a little bit more challenging just in the fact that there is a negative right there. I want you to rewrite this whenever you see something like that to something like this. Negative 1 groups of 2 minus 3x and then plus 4. This plus 4 is at the end. I'm going to wait for it. I'm going to do it last. So let's distribute the parentheses first. Since I have a negative sign right there, that's the same thing as saying negative 1. Negative 1 times 2 is negative 2. Negative 1 times negative 3x is positive 3x. Again, negative times negative. And then I drop the positive 4. Squiggly, squiggly. Those are both integers. Double line. Nothing else has an axis, so that's going to be by itself. So negative 2 combined with positive 4 will be 2. Drop the 3x. And there's my final solution. I can't simplify it anymore. Okay, so that's how you guys would do the distributive property. Again, it's going to look something like this if you want to take down the A times B plus C. The fastest way to do the distributive property is AB plus AC. And those are just numbers, any integers, rational numbers that we want. Alright guys, make sure you guys list this in your notebook. Slow it down if you have to. Pause the video, take down the examples, and we'll go over in class. Thanks guys.